and we're going to go over transforming functions. And this is function notation for how to transform any function. Okay, so f at x is essentially a function with the variable x in it. And this f here in the middle of the equation is referring to the type of function we're using. So whether we're using a parabola, a root function, if we're going to use a cubic function, an absolute value, all of those can replace this f value here. And what's most important is what it's saying is this a, k, d, and c can be applied to any possible function, and they'll roughly do the exact same thing. It'll just maybe look a little different per function, but the ideas are always the same. Okay. Now, our a value does vertical stretches and compressions. So I'm going to say stretches, compressions, and technically reflections. Okay. The c value does vertical translations. Okay, so in other words, it's going to move things up and down, while the a value, depending on what number it is, depending on what a value it is, if it's greater than 1, then it's going to stretch things. If it's between 0 and 1, it's going to compress it. And if it's a negative, it's going to make it a reflection on the x-axis. The k value, okay, does horizontal stretches, compressions, and reflections. Okay, and the d value does horizontal translations. So with all that information, we can actually apply it directly to a coordinate. Okay, so depending on whether we have an a, k, a d, or a c, we can directly apply them to some coordinates, so some x, y value. So say we had the coordinate of, oh, I don't know, 1, 2. Okay, and that was our x and our y value. Essentially what that's saying is we can plug 1 in for our x here, and depending on what the k is, we would divide that value by k, and then we would subtract it by the d value to find out where the new coordinate would be, so the shift in it. The same idea is that y value, say it's 2, well, we take whatever a value we have, and we multiply it by 2, and then we add c, and that's where the new y value would be. Okay, so to give you an idea of something like this, we're going to talk about a root function, because it's something we haven't really worked with too much. Okay, I'm going to write some values out. So we have 5 times the root of, and we'll have maybe 2x minus 3. I don't need the root function to be so long. Plus, oops, let's say plus 4. Okay. What we're going to do is we're going to pick out our values here. Do you know which of these numbers represents the a value?
The 5.
The 5, that's right. This would represent the a value. So in other words, this is being stretched, right? Because it's greater than 1. So because a is greater than 1, then we're getting a stretch. Okay, so it's being stretched by a factor of 5. Okay, what would be the c value?
4.
4, that's right. And what's happening here is because it's positive 4, it's being translated upwards 4 units. Okay, what would be the k value?
The 2.
Okay, so our 2 here, because it's greater than 2, it's actually being horizontally compressed. Okay, so this is horizontal, so we're going to say our k value is greater than 1, so it's being compressed by a factor of 2, and we'll show you what that kind of looks like. And our d value, which is our negative 3, okay, because it's a negative, we're actually going to move to the right by 3 units. Okay, so it's actually moving in a positive direction, so I'm going to put positive 3. So opposite of what we normally think. Now, the original of this equation would be f at x is equal to the square root of x. Okay, and we have all these movements to it. So what we're going to do is we're going to open up a new graph and take a look at these two. So at 5, 2, negative 3, 4. So if I have the square root of x, this is the function we get. Okay. Now remember the numbers we had were 5 square root of, I think it was 2 bracket x minus 3 and then plus 4. Okay. So a very different looking function. I can't quite hit that value here. Just like I get this one here. This is a very different looking function. Okay. Now the reason I'm highlighting 3 and 4 is because I want to draw your attention to what 3 and 4 are in comparison to the original equation. So this over here. Okay. This value here, 3 and 4, is actually in reference to the 3 and the 4 here. They're telling us where the origin has moved from. In this equation here, technically it's x minus 0, and then outside of the equation it's plus 0. So the origin is actually telling us a coordinate, okay? So it's actually referring to that, and what's happened is we've moved to the right 3 units. If you notice, we've gone 1, 2, 3 units to the right, and then we've gone 4 units upwards, 1, 2, 3, 4. So that's what the 3 and the 4 are talking about. So we've taken this major point and moved it there. Okay, so those are our translations, the 3 and the 4. But what's also happened is our value has been vertically stretched, so it's been pulled upwards by a factor of 5. Okay, and it's been horizontally compressed by a factor of 2. So it's a very big effect. If you notice, it used to go like this, and now it looks like it's almost heading in a vertical direction, right? If we zoom out, right here, if we zoom out, we can see how very different these two functions start to look. So let's look at this on a one-to-one basis. Okay, so I'm going to get rid of our blue one for now. Let's say we have our root of x, and the first thing we want to do is move it up 4 units. Okay, so I put in plus 4, and if you notice, we'll zoom in again, this coordinate has essentially moved up 4 units, right? We've essentially gone up 1, 2, 3, 4 units to here. Okay, the next one that would be good to look at would be our 3. So square root of bracket x minus 3, okay? And if we notice again, this is the idea that we've now moved over 1, 2, 3 units to the right, okay? When we put both of them together, okay, so put them together in a function, we get the square root of x minus 3, okay, and then plus 4. And what's happened, just like we said, we've gone over 1, 2, 3 units and up 1, 2, 3, 4 units. Okay, so the whole thing is moved, but we haven't been horizontally or vertically compressed yet. Okay, so let's look at those on an individual scale also. If we have 5 square root x, in comparison, this has been vertically stretched by a factor of 5. Okay, you'll notice the origin hasn't changed, that one point hasn't changed, but it's been pulled upwards by a factor of 5. Okay? We'll look at another one. And we have x and the value of 2. Okay? Again, this one here, this being the same, this has been horizontally compressed, so it's been pushed in. So it's almost like a wall is being pushed in this way, and it's causing this to kind of come up more and more. It's crushing it to the side. And that's what it looks very, very similar, if you notice, to the vertical stretch. But it's actually a horizontal compression. Okay? And together, okay, so I'll show you what they both look like together. This is very exaggerated, what has happened in this stretch. So number 2, x, right? And you'll notice how big of a difference this was from the other two. This one was 2, this one was 5, and they've been put together to make what our blue line is here. Okay, so it's very, very different looking. And when we put everything together, that's essentially where we get this. Our coordinates here, okay, and that's where we had this guy. That's the original without the stretches and compressions. And this guy here. So we've taken this blue one and moved it up to this point for this blue one being our new function. Does that kind of make sense there?
Yeah.
Okay. So that's exactly how we've moved everything around in this question. Another way we could figure out exactly where a coordinate would be is we can go point by point. So we're going to take a look at a major point in this equation here. And one of the points I want to look at is at the point of 16 and 4. We can get, there it is. So one of the coordinates along the originals, the red ones the original we have, is 16 and 4. So I'm actually going to highlight that. 16 and 4. Okay, so that's at 16. Oh, when I go slow, it comes out really nice. Oh, good. And 4. Okay, so that's one of our major coordinates. And what we're going to do is we're going to apply our changes to the numbers 16 and 4. Okay, so we're going to keep that in mind. I'm going to go back to the other page. We'll apply the changes and then see where our new coordinate, or this one, should show up. Okay, so that coordinate 16 and 4. Okay, remember we had our xy here. I'm going to redraw it down here. We have 16 and 4. And if you recall from our equation above, we can take that value divided by k and then minus by d. So we're taking 16. We're going to divide it. What's our k value?
4. I mean, no. 2.
Yeah, it's 2. And then our d value. What is our d value here? 3. So we're going to subtract negative 3. Okay, subtract negative 3. Think of it like the negatives on the inside of the bracket. Okay, and our other coordinate was the number 4. It says the a, we multiply by the a value. Well, the a value is 5 in this case. And we add our c value. So we're going to add 4 to it to find out what these new coordinates would be. Okay, so this is our x and our y. So 16 divided by 2 will give us 8. And then 8 subtract negative 3 is like adding 3. So we actually get a coordinate of 11. Okay. And over here, 4 times 5 is 20. And 20 plus 4 is 24. So what this is saying is our coordinate from 16,4 has now moved to 11,24. Okay, so we're going to take a look and make sure that actually exists, and then we'll talk about how it got there. So like we said before, we had a coordinate at 16 and 4. And we're going to show you a coordinate along here that's at 11 and 24. And there we go. That's actually a coordinate on there. Let's plug that in. 11. It's 11 and 24. Okay. So what's happened here? Okay, is this specific coordinate? Okay, has been shifted to the right 3 units. Okay, then it went up 4 units. Okay, then it was vertically stretched by a factor of 5. So think of this like, oops, that's not what I want to happen there. Okay, it's vertically stretched by a factor of 5, and then horizontally compressed by a factor of 2 to end up at this new coordinate of 11 and 24. Okay, so it went through all those transformations to end up at its new coordinate right there.